to the all exam formula sheet, and that very last page, it has the conic section, right? The parabola, the ellipse, and the hyperbola. The formulas that are on this all exam formula sheet that deal with conics, they are for conics that are centered at the origin. Right, so for each one of these, and there's actually some formulas, we're going to take a look at them. But each one of these conics, the parabola, the ellipse, and hyperbola, they're centered at the origin, which means that their vertex is at the origin. The formula sheet that I passed out in the lecture note, well, in the formula sheet section, is labeled under conics. And let me just bring that up. These are the formulas for the conics that are not at the origin. It is a different set of formulas. Okay, so the ones on the formula sheet, on the all exam formula sheet, are for conics centered at the origin. This second formula sheet is for conics that are not centered at the origin. Okay, and we'll see the differences in a second. Before we begin, there's a prerequisite college, it was in the college algebra course. A prerequisite skill for this section is completing the square. So before we begin, we will kind of touch on how to complete the square, okay, because there's a fair amount of this in this particular module. All right, so as far as the conic sections are concerned, we're no longer dealing with sines and cosines and tangents. This is more so like an algebra type section. So this is completing the square. So in order to complete the square, you must have a certain form, all right? You must have your second degree term, and you must have your first degree term. The coefficient of your second degree term, when I say second degree, that's just the variable with the squared exponent. The coefficient must be 1. All right, this is the form that you must have. Once you have this form, you can complete the square by taking half of the coefficient of the middle term. So I'm just kind of writing this out theoretically, but I will put an example to it. You have to take half of the coefficient of the middle term. So I'm going to take the coefficient of the middle term divided by 2, and then we're going to square it, right? So to complete the square, take half the coefficient of the middle term square All right, so you basically take half of the coefficient of the middle term and you square it. Once you complete the square, you force what is called a perfect square trinomial, right? Which can be factored down to, right, a factor form. All right, so this is how this actually looks as far as a problem is concerned. All right. So let's just say you have x squared plus 4x is equal to 2 or something like that. Okay, so x squared plus 4x is equal to 2. I can complete the square on this left-hand side, right, because I have the second degree term, its coefficient is 1, and I have my first degree term. So I'm going to write out x squared plus 4x, and I'm going to put plus blank. All right, so that blank is going to be half of the coefficient of the middle term. All right. So up to this point, I haven't added anything that wasn't there. I started with x squared. I have x squared here. I started with 4x. I got 4x here. I started with a 2, and I got 2 on my right-hand side. So in order to complete the square, I'm going to take half the coefficient of the middle term, and I'm going to square it. All right, so the coefficient of that middle term is 4. We divide that by 2, and then we square it. So 4 divided by 2 is 2, and 2 squared is 4. So now I have added something to one side. So remember, the properties of equalities tell us whatever you add to one side, you have to add the same thing to the other side. So notice I have an x squared. I started with x squared. I have a 4x. I started with 4x. I added a 4 to this side. So I must add a 4 to the opposite side. All right, so that's one of the things here. Once you complete the square, you force what's called a perfect square trinomial, but you have to maintain equality. So whatever you add to one side, you got to add to the other. So now here's that perfect square deal. X squared plus 4x plus 4, that can be factored down to give you x plus 2 quantity squared is equal to 6. The 2 I'm going to try to change the color. Comes from half of the coefficient of the middle term. Right? So this x, the magic number in order to complete the square is whatever half of that middle term is. So if you were to take x plus 2 quantity square, and if you were to multiply x plus 2 times x plus 2, you're going to get x squared plus 4x plus 4. Now you can solve this by using the square root property or whatever, but I just wanted to show how to complete the square. All right, so just take half of the coefficient of the middle term and square it. All right, so now you're going to see that later on. I just wanted to show it prior to the lesson. All right, so now we're going to take a look at the formula sheet with the conics that are centered at the origin. And we're going to start with the parabola. Okay. So there's 4 different shapes. We have a C shape, a reverse C shape, we have a U shape, and we have an upside down U shape. Okay. Now, as far as a parabola is concerned, a parabola is a quadratic equation because the largest variable is squared. So up until this point, when we talked about a parabola or the quadratic formula, it mainly looks something like this. Y is equal to ax squared plus bx plus c, right? This would be the standard form of a quadratic. Okay. And then when you graph a quadratic equation, the shape it produces is a parabola, right? A U-shaped curve. All right. But you're going to notice the formulas on this formula sheet are a little bit different. They're not written out as ax squared plus bx plus c. They are written out as y squared is equal to 4ax. So this is the equation, and then this is the graph that it produces. So notice that there's only one variable squared. It's either going to be the x squared or it's going to be the y squared, but never both if you're talking about a parabola. The second one is y squared is equal to negative 4ax. So notice how this produces a reverse C shape. And then we have x squared is equal to 4ay. So notice that it produces a U-shaped parabola. And then x squared is equal to negative 4ay. It produces a reverse U-shaped parabola, right? That's pointed down. These model forms produce these graphs. So we're going to take a look at, well, I'm going to start with this one first. X squared is equal to 4ay. So these are for the parabolas. X squared is equal to 4ay. So notice how this will be the standard form of a parabola. My x squared term is on the side of the equation by itself, and its coefficient is 1. All right, so x squared is equal to 4ay. That produces a graph that looks like this, and this is centered at the origin. We have something called a focus. So here's what a focus is. Like in a satellite dish, and I think satellite dishes are like obsolete. I ain't seen a satellite dish since the wireless stuff's going on. But for a satellite dish, or if you got Dish Network or somewhere there to come put the dish in your yard, it looks something like this, right? So what happens is, so this is what actually sits in your yard. So what happens is you have a satellite, and this is my best drawing of a satellite, and it's like sending out some signals, right? What happens is the signals hit the base, right, from this parabola, and then they reflect to the focus or the receiver, right? So the rays bounce in from the satellite, they hit the cone of the dish, and once they hit the cone of the dish, they reflect to what's called the receiver. So that's why the satellite dishes are like parabola shaped, all right, because of this main focus concept. So if your equation looks like this, x squared is equal to 4ay, this is your graph. Your focus is going to have the points 0, a. So I'm going to call that F for focus. And the vertex, I'm sorry, is 0, 0. I should list that first. The focus is 0, a. You also have something called a directrix. The directrix, if we take a look back at the formulas, I'm actually looking at this one first. All right, so we're looking at x squared is equal to 4ay. Since a is positive, it forces a U-shaped parabola. Our focus has the coordinates 0, a, and then we have a line that's called the directrix. The directrix has the equation y is equal to negative a. So this line that I'm actually drawing at the bottom, this is the directrix. I'm going to call that D, and it has the equation y is equal to -a. Now here's the deal about A. I'm going to blow this up. A is either the distance from the focus to the vertex, and that's the same distance as the directrix to the vertex. So that's why A is so important. If you pull out A, you can find the coordinate for your focus. You can also find the equation for your directrix. So A is the distance from the vertex to the focus, or A is the distance from the directrix to the vertex. Okay, so that's like the significance in finding A. If you find A, you can simply substitute that in for your focus, and you can substitute that value in for your directrix. Okay, so that's true for all of these conics that we're going to talk about. All right. So now let's look at the second type. X squared is equal to -4ay. So notice here the coefficient of your y variable is negative, right? Or a is negative. So if this is your model form, your graph is going to look like this, an upside down U. The vertex is 0, 0. The focus is going to be here, right? So what do you think the coordinates for the focus would be? Well, the coordinates for the focus here are going to be 0, -a. Right? Because this point, right, the x coordinate is 0. I don't know if you can see that. The x coordinate is 0, and I'm going down a, right? So it's 0, -a. And the directrix has the equation y is equal to +a. So this is F, this is V, and that's D. It kind of helps if you sketch these things out versus the first time you're doing this versus just looking at that formula sheet. Looking at that formula sheet with the conics, it can be kind of overwhelming. All right, so any questions about the x squared model form? So notice when they ask you to write these equations in standard form, what they want is the squared term on the side of the equation by itself and everything else on the other side. So notice that either the x is going to be squared or the y is going to be squared, as we're going to see for the y squared equals types, but never x and y squared. It's either one or the other. All right, so let's look at the second set of model forms. So we have y squared is equal to 4ax. So notice this time the y is squared, okay, and it's on the side of the equation by itself, and it's equal to 4ax. If this is your model form, your graph has a C shape. The vertex is 0, 0. the focus is going to be here, right? So what do you think the coordinates for the focus would be? Well, the coordinates for the focus are going to be a comma 0. Because remember, a is that distance from the vertex to the focus. A is also that distance from the vertex to the directrix. So what would you think would be the equation for the directrix? So notice now this is a vertical line. So that's an x equal to type equation. So the equation for the directrix is x is equal to negative a. All right, so that's the model form and the graph and the formulas for y squared equals to 4ax. So now here's the last model form. Y squared is equal to negative 4ax. Right. So since the coefficient for x is negative, when we graph it, it's going to have the reverse C shape. The vertex is at 0, 0. The focus, right, the focus is going to be on the inside of where that parabola opens up. The focus is going to have the coordinates negative a comma 0. And then we have our directrix. So the directrix has the equation x is equal to a. All right, so for the parabolas, in this case, centered at the origin, the vertices are all 0, 0. In order to determine the focus, right, the focus is going to be on, it's going to lie on the inside of the opening of your parabola. So a is that magic number, right, to find the focus coordinates. And it's also the magic number to find the directrix. Okay, so any questions about these model forms? Now these formulas are on the formula sheet, but they're kind of written out in the diagram. All right, now so let's take a look at some problems. All right, so the first one says determine. Okay, I'm going to explain about the ones centered at the origin and ones that are not centered at the origins. Okay, so taking a look at the handouts from the all exam formula sheet, just notice the model forms, right? Y squared is equal to 4ax, y squared is equal to negative 4ax, x squared is equal to 4ay, x squared is equal to negative 4ay. If you take a look at that handout I passed out, notice that these model forms are totally different. If we look at this first model form, it's not x squared, it's x minus h. I didn't give you one, I'm sorry. Okay, so if you look at this first model form, it's not x squared minus 4ay. So they're using p instead of a. And then I believe in the view and example stuff, they may use C. All right, but all of that's one and the same. Notice that this is x minus h quantity square is equal to 4a or 4p or 4c times y minus k. Whenever you have the h and the k attached to your equation, you have a conic that's not at the origin. All right, so notice this, just to give an example. X minus h quantity squared is equal to 4p times y minus k. That will look something like this. X minus 3 quantity squared is equal to 4 times y plus 2. That's a parabola, right? But I have a vertex other than 0, 0. All right, so we're going to talk about what happens when you have a vertex other than 0, 0. So looking at this problem, it says determine whether the given equation is a parabola. If so, write it in standard form. And notice they just show you this. And this is the equation or the equations for conics not at the origin. But for mine, I just have a y is equal to 1 over 36x squared. I don't have a coefficient attached to y, and I don't have a constant attached to y, and I don't have a constant attached to x. Right? So this is at the origin. So we're going to write it in standard form. So remember, standard form just means that your squared term has to be on the side of the equation by itself. So in order to write that in standard form, this is 5.1.1. Right, in standard form. And what was the question? Y is equal to 1 over 36x squared. Right. So the first thing I'm going to do is get the x squared variable by itself. So I'm going to divide both sides by 36. So if I divide the left-hand side by 36, I have 36y. If I divide, and that should be multiplied. Right, so if I multiply the left-hand side by 36, I get 36y. If I multiply the right-hand side by 36, the 36 cancel, and I have x squared. So I have 36y is equal to x squared. So I'm just going to reverse it. Right, so it kind of looks like the model form. But the standard form, I have to factor out a 4 some kind of way, because it is x squared is equal to 4 times a times y. So what I'm going to do in order to pull out the 4 is I'm going to divide by 4. If I divide 36 by 4, I get 9, right? So I can write this as x squared is equal to 4 times a times y. So 4 times 9 is 36. Okay, so I'm going to write it out as x squared is equal to 4 times 9 times y. Right, so that's how they write that out. X squared is equal to 4 times 9 times y. I put in x squared is equal to 36y, and it did not like that for whatever reason. So I'm going to write everything in this form where that 4 is factored out. Okay, because if I put that in, I did that earlier, x squared is equal to 36y. If I just put that in, for whatever reason, it doesn't want it that way. So they specifically want you to write out that 4. And I don't know, okay, yeah. It specifically wants you to write it out as 4 times some value times y. All right, question number 2 says determine whether the equation is a parabola. If so, write it in standard form. This is 6x squared minus 10y squared is equal to 2. Is that a parabola? It's not a parabola, right? Because in a parabola, either the x is squared or the y is squared. So that's not a parabola. Okay, we're going to talk about these types when we talk about the ellipse and the hyperbola, but that's not a parabola. All right, the third question says determine whether the given equation is a parabola. If so, write it in standard form. So we have y minus 1 quantity squared is equal to 12 times x minus 2. So that's written out as a conic or a parabola that's not at the origin, because y minus 1, and then I have x minus 2. So it would be a parabola because only the y is squared. Now, the only thing I want to do to write that in standard form is to write it out as y minus 1 quantity squared is equal to 4 times some number times x minus 2. So 4 times what is going to give us 12? 3, right? So that would be 4 times 3 times x minus 2. So they specifically want that standard form written out as 4 times some value. So that's the only thing you have to do for number 3. Now this is number 4. It says rewrite the given equation in standard form. Then we have to find the vertex, the focus, and the direction. And that's y is equal to 1 over 28x squared. And this was number 4. One over 28x squared. All right, y is equal to 1 over 28x squared. So the first thing we're going to do is write in standard form. All right, so just like we did for the first problem, I'm going to multiply both sides by 28. Right, so we multiply both sides by 28 so we can get the squared term on the side of the equation by itself. So when we multiply the left-hand side by 28, we get 28. I multiply 28y. I don't want to forget my variable y. Multiply the right-hand side by 28. The 28's cancel. We're left with x squared. And then I'm just going to rewrite it and put that squared variable on the left-hand side. So now to write it in standard form, it should be written out as x squared is equal to 4 times some number times y. So 4 times what is 28? 7. So this would be our standard form. All right, so any questions about that? All right, 2, what's the vertex? All right, well, since it's in x squared is equal to 4 times 7 times y, I don't have a constant attached to x or y. So this parabola is centered at the origin. So its vertex, and remember the vertex is where that parabola bends, it has the coordinate 0, 0. Okay, the third thing is we want to find the focus. All right, so this is where the formulas come in. So in order to find the focus, first off, I want to look at the model form. It's x squared is equal to 28y, right? And that 28, which is the coefficient of y, is positive. So if we go back to our model forms, I believe that would be this first model form, right? Because x squared, the x is squared, the coefficient for y is positive 28. So we factored out 7, right, to give us the magic number for A. So what would be the coordinates for the focus? It would be 0, comma A, or in our case, 0, comma 7. We could also write the equation for the directrix by knowing that value A. So if A is 7, the directrix is going to have the equation y is equal to -7. So once you have your model form and once you have A factored out, then you can look at the right model form and just substitute A to find the focus and the directrix. So our directrix is, or our focus is, I gotta go down, 0, comma 7. And our directrix is y is equal to -7. All right, so it's standard form. So now they have x squared is equal to 28y, but I would write it as 4 times 7 times y. Okay, they will accept that. The vertex is 0, comma 0. The focus is 0, comma 7. The directrix is y is equal to -7. Okay, number 5 works the same way, but there's one difference. The squared variable. Here we have y squared instead of x squared. So this is x is equal to 1 over 24 y squared. X is equal to 1 over 24 y squared. And this is number 5. So we want to write standard form. Okay, so here we want to isolate for our y squared variable. So the opposite of multiplying y squared by 1 over 24 would be to multiply both sides by 24. So if I multiply both sides by 24, I'm going to get y squared is equal to 24x. I just kind of flipped it around. And to write this out in standard form, it should be y squared is equal to 4 times some value times x. So 4 times what will give us 24? It's going to be 6. This is our standard form. Right? Y squared is equal to 4 times 6 times x. The second thing is we want to find the vertex. So here again, since we have a y squared with no constants attached and an x with no constants attached, this parabola is centered at the origin. Okay, now we're going to find the focus. So I'm going to look at my equation, which is y squared is equal to 24x. So my y is squared. My coefficient for x is positive. So I'm going to look back at the model forms. And it looks like that third one, right? Y squared is equal to 4ax. The y is squared. The coefficient for x is positive. So the formula for the focus is a comma 0. And we factored out a is 6. The directrix is x equal to negative a. So that's going to be x equal to negative 6. So to find the focus, we use the model form for y squared is equal to 4ax, and we have the focus is 6 comma 0, and the directrix is x is equal to negative 6. All right, so just looking back at the, all right. So standard form, vertex, focus, and the directrix. All right, now number 6 and number 7, you have to complete the square. So number 6 says you write the given equation in standard form and then find the vertex, the focus, and the directrix. So let me write that down. That's y squared plus 6y minus 16x minus 7 equal to 0. That's number 6. Y squared plus 6y minus 16x minus 7 is equal to 0. First thing I'm going to do is write in standard form. So this is why you have to complete the square. In college algebra, when you completed the square, it was kind of well, I'm not going to say it was pointless, but there was like no end goal in that. But for the trig class, in order to complete the square, notice that we have a y squared variable, and then we have a y variable. For our model forms, there's only one y, and this y squared is equal to 4ax or whatever, right? So we complete the square in order to rewrite this as a single y. So this is what I'm going to do. I'm going to isolate the y's. So what I mean by that is y squared plus 6y. I'm going to let that stay on the side of the equation by itself, right? Because that's the form that we need in order to complete the square, right? And I want to move everything else to the other side. So negative 16x, I'm going to move that to the other side. And whenever you move entire terms across that equal sign, you simply just change the sign, right? So I'm going to add 16x to both sides. And I'm going to add 7 to both sides. Right, I move negative 16 across the equal sign. That changes that negative 16 to positive. And I move negative 7 across the equal sign. That changed the negative 7 to positive 7. Right? Now we're going to complete the square for the y variable. All right, so we have y squared plus 6y plus blank is equal to 16x plus 7 . And let me just see if I knock this offline. It should still be recording. Okay. All right, so any questions about the blanks? To complete the square on the left-hand side, I got to take half of the coefficient of the middle term. So we're going to take the 6, we're going to cut it in half, and then we're going to square it, right? 6 divided by 2 is 3. And then 3 squared is what? Oh, 9. That's way too big. All right, and then 3 squared is 9, right? So we added something when we completed the square. We added a 9, right? So since we added a 9 to the left-hand side, we have to add 9 to the right-hand side. Right, so is everybody okay with that? Uh-huh.
If it's a -6 and we cut it in half, we can still, it doesn't matter if it's negative or positive.
That's right, because when you square it, it's going to always throw back a positive. Okay. All right, so now on the left-hand side, we actually produced a perfect square trinomial. So I'm going to write this as y, and then I'm going to take half of the coefficient of that middle term, which was 3, squared. So that's where that 3 comes from. When you take half of the coefficient of the middle term, you get 3. Now, if it were like a -6, I would have a -3 on the inside. But when you square that -3, it throws back a positive. So whatever you get when you take the middle term and cut it in half, that's the magic number. It could be positive or it could be negative. That's equal to 16x and 9 7 plus 9 is 16, right? Plus 16. So we have the left-hand side where we want it. But for the right-hand side, we got to write this as 4 times something times x. Right. So I'm going to bring down the left-hand side, y plus 3. On the right-hand side, I'm going to factor out 16. So if I factor out a 16, I'm going to have x plus 1 on the inside of the parentheses, right? Because 16 times x is 16x. 16 times 1 is 16. Okay, and now I'm going to go the final step in so 4 times what would give us 16? 4, right? So 4 is going to be C or A or P, whatever model form you're looking at. And I'm sorry, the y plus 3, that still has that square on it. Right? So that y plus 3 is still squared all the way down. And this is our equation in standard form. Y plus 3 quantity square is equal to 4 times 4, right, which is 16 times x plus 1. All right, so we just take a look at that. All right, so that's what that y plus 3 quantity square is equal to 4 times x plus 1. Any questions about the first part? To find the focus, the directrix, the vertex, the focus, and the directrix, since this is not at the origin, we're going to use the formula sheet that I passed out to you. Which is this one. And can I put them on the same? Just try to blow both of these up. Okay. So now just one thing about this formula sheet. On the parabola centered at the origin, there were like 2 sets of formulas, right? We have x squared is equal to 4ay, and then x squared is equal to negative 4ay. On this formula sheet, everything is condensed into one set of formulas. So if I'm looking at the formula sheet, notice that I see an up parabola, I don't see the down one, right? That's all dependent upon if your p-value is positive or negative. Okay, you just follow these formulas. Same thing for the left and right. They only show the right, but this would apply to the left too. You just simply have to make p negative in all of these formulas. All right, so we have y squared, y plus 3 quantity squared is equal to 4 times x minus 1. Since the y variable is squared, that's going to produce a C-shaped graph, right? Because remember, if x is squared, it's either up or down parabola. If y is squared, it's either C-shape or reverse C-shape. Since the coefficient of x is positive, then this is the correct curve. All right, so is everybody okay with that part? Just locating down the right model form. What's the vertex? The vertex is going to be in this form. That's the second thing, find the vertex. The vertex is going to be in this form, h comma k the signs will change when you take them out of your equation. And I'm just going to explain that. So remember, if I'm looking at this model form, H always follows X. K always follows Y. The vertex is specifically H comma K. So in order to find the first coordinate of my vertex, I want to know what follows X. So I have X plus 1. But when I take this plus 1 out of my equation, I have to change the sign to -1. And I'll explain why we change the signs in a second. K follows Y. So I'm looking over here and 3 follows Y, but it's positive. So when I take that out of my equation, it becomes -3. So my vertex is -1 comma -3. H follows X, K follows Y, and the signs will change. So is everybody okay? I'm writing this as -1 comma -3 and not what I see. I see the 3 first. But just remember that H follows X, K follows Y. Here's why the signs change. Because if I'm looking at this model form, right, and if my vertex is -1 comma -3, when I substitute in -1 for H, I have X minus a -1, which is a what? +1 in my formula. When I substitute in K for -3 in this model form, I have Y minus a -3. And that double negative is going to give me what kind of 3? A +3 in my formula. So your signs will change for your vertex. Is everybody okay with the vertex? Okay. Next, we have to find the focus. So in order to find the focus, I have to look at the formulas for the focus. So let me just bring this up on a page by itself. So now here's the formulas. The focus, well, we have the vertex, which is H comma K, right? So we pull out H, which follows X. We pull out K, which follows Y. We change the sign. Here is the formula to find the focus point. Is H plus P comma K. We have to find the directrix. This is the formula for the directrix. X is equal to H minus P. Okay. So here's the formula for the focus. Here's the formula for the directrix. So to find the focus, we're going to use the formula. The focus is H plus P, comma, K. What is H? Well, H is going to be -1, right? What is P? P is going to be 4, because P, A, and C is all depending on which formula sheet that you're using. But P is going to be 4. Oh. And what's K? K is going to be -3. This is just all the way back. K, -3. Is everybody okay with where I'm pulling these values from? Right, H was -1, because remember from our vertex, we have H comma K, right? We had to change the signs, right, once we pulled them out of our model form. So H is -1. P, once we write it in standard form, right, 4 times P, A, or C, right? So we got 4. So P is 4 and K was -3. So the focus are going to be at the coordinates -1 plus 4, comma, -3. So our focus should have the coordinates 3, comma, -3. So our focus has the coordinates 3, comma, -3. Now let's find the directrix. So I'm going to look at the formula sheet. Find the right model form, which is here, the C shape. And the directrix has the formula X is equal to H minus P. So the directrix has the formula X is equal to H minus P. So H is what? Well, if we go back to our vertex, H is -1. And what is P? Well, if we go back to our formula, P was 4, right? So I'm just going to substitute H and P into the formula. So we have the directrix is equal to X is equal to -1 minus 4. So the directrix should be X is equal to -5. So it's like if it's not at the origin, it's kind of formula intense, where you got to look at the formulas and then figure out X, H, and P, substitute all of that stuff in. So if we just go back and check this out, the vertex is -1, comma, -3. The focus is 3, comma, -3. and the directrix is x equal to -5. All right, any questions about number 6? All right, number 7 works about the same way. All right, I'm going to let you try number 7. All right, just isolate the x on one side, complete the square, use the right formula on the formula sheet. All right, and you have to use the formula sheet that is not centered at the origin. Okay, it's the same as problem number 6. All right, now the last two, 8 and 9, they want you to graph. So 8 says graph the parabola, the focus, and the directrix for the parabola, plot the vertex, and then plot another point with integer coordinates. So let's take a look at this one. Y is equal to 1/10 x squared. All right, so y is equal to, I think this should be good. Y is equal to 1/10 x squared. And we're asked to graph. So first thing I'm going to do is just put it in standard form because we got to find the focus. Then we got to do an x and a y chart to find some coordinates. But putting it in standard form is going to allow us to plot the focus and the directrix. So y is equal to 1/10 x squared. So we're going to write in standard form. So I'm going to multiply both sides by 10. So we get x squared is equal to 10y. Right. So this is going to be x squared is equal to 4 times some number times y. So 4 times what is going to equal to 10? So 4 times what number is equal to 10? I can divide both sides by 4. And if I reduce 10 over 4, I get what, 5 halves? So that's going to be 5 halves. Does everybody agree with that? Because if you multiply 4 times 5 over 2, right? 4 times 5 is 20. 20 divided by 2 is 10. So 5 halves is that magic number. That's the distance from the vertex to the focus or the distance from the vertex to the directrix. So that's going to be needed on the graph. All right. Since this is in the form x squared is equal to 10y, from that model form, I know that my parabola, first off, is centered at the origin. Secondly, it's going to be a U-shaped parabola, right? So it's going to look something like this. I can plot my focus and my directrix, right? So if I take a look back at the model forms, I believe it would be this first one, right? X squared is equal to 4ay. So the focus is 0, a. The directrix is y is equal to -a. So my focus, get back to it, should lie at 0,5. The directrix is y is equal to -5/2. Right, so 5/2 is like what, 2.5? So 2.5 would be like here. I'm gonna plot it in the XYZ homework. And then y is equal to -5/2 would be like here. Right. But then I have to find some points on my curve to make sure I'm actually graphing my parabola the right way. So I'm going to do like an X and a Y chart because I got to find a point on the line. So we wrote it in standard form. The second thing we did was find the focus. The third thing we did was find the directrix. The fourth thing we're going to do is find a point on the line. So we have x squared is equal to 10y. And if I do an x and a y chart, you can either substitute in a number for x or substitute a number for y. I'm going to substitute in a number for y. And I want to make sure the number that I substitute in, I'm going to be able to take the square root. So I'm going to say that y is 10. Right? So I have x squared is equal to 10y. Y is equal to 10. So x squared is equal to 100. And then if I use that square root property, x is going to equal to plus or minus 10. So I have 10, 10 and -10, 10. I just want to make sure that these points are on my curve. So any questions about what we did? Just to review. We took the equation, we wrote it in standard form. By writing it in standard form, you can pull out the quantity for A. A is needed in your focus and your directrix. So we wrote it in standard form. We found 5/2 was the value for A. We located the right model form. We were able to write out the focus and the directrix. Next thing we need to do is find a point on the line, right? So we found 2 points. So like 10, 10, right? That would be this point. And then -10, 10 would be this point. And then our graph is going to look something like this. All right. So let's graph that in XYZ homework. All right, so the directrix or the focus is 2.5. That should be my directrix. Y is equal to -5/2. It's centered at the origin, and I should have that point on my line.